Hello everyone, my name is Katie Greenslade. Today I will be going over my ECE 5000 final design project, which is a building occupancy counter. Are you sick of having employees constantly forgetting to sign in and out of the building, and you never truly know the building occupancy level? Or say an employee goes to work extra hours on the weekend, but they forget to sign in, and then they end up having an emergency. You go to look, you see no one is in the building, but really, there is someone in the building. You don't notice till Monday that they had an emergency. To prevent this problem, you can use our bidirectional occupancy counter, which has precisely measures how many people are in a building. And you can access the count remotely. Say you're a supervisor, you can just quickly check on your phone and see, oh, someone's in the building, but they shouldn't be, and you can investigate, potentially saving lives. Or are you in a pandemic where government mandates all buildings have a maximum capacity? You don't want someone using a clicker, say they get distracted, 5 people walk by and your building capacity can just go way off. With our product, you have a precise measurement of the building occupancy at all times, and it precisely measures people entering and leaving. And it takes away human error from a clicker. Or are you on a work site where there are multiple safety concerns, say a high voltage site, or it could range to a coal mine or a lab, and you want to know if someone is in the site when they shouldn't be? This could prevent medical emergencies or an emergency where they get shocked by high voltage. There are so many safety concerns on these sites, you need to know the occupancy at all times. Again, you can use our bidirectional people counter, which precisely measures the occupancy at all times, and you can remotely check it on your phone, preventing emergencies and being able to save lives realistically. Again, solutions. Greenslate's design building occupancy counter. This counter uses 2 IR sensors with a range of approximately 80 centimeters, which will cover your standard door frame. And the count is bidirectional, meaning you only need this small design here on the bottom right, and it will count people coming in and out in both directions. The logic of this counter, there are 2 sensors. If sensor A goes off first in a time frame, then someone is entering. If sensor B goes off first, then that means someone is leaving. The count will update on all 3 devices, the LCD screen, remote read, and local display. The design is very small and durable and is easy to install anywhere. The product. So again, it features 2 IR sensors, which allows a bidirectional count, which is very important. The 2 IR sensors allow the product to be in the smallest possible design, and this allows easy installation. You only have one tiny box you need to install next to a door frame, and then it will count the occupancy. There's a local LCD screen that will display the count, and it is also mounted onto the box, as you can see on the bottom here. That's what the LCD screen looks like. So this is definitely the smallest, most compact design. As you can see in the top right, this is the internal wiring of the box, and there is a lot of wires required for this design. But it is very compact, and the wiring is very neat, and there's also a soldering board which allows permanent connections as required. And there's local and remote access to the count via Node-RED. On the bottom right here, you can see the Node-RED gauge, and it is very simple to read. Currently is at a count of 10. This screenshot is different than the LCD screen. They take it at different times, but they would normally display the same count. They're just taken different times. So today, the test agenda, first I'm going to show you the project and show the internal wiring and just go over the project and what it looks like. Then I'll show you the manual increase, decrease, and reset buttons. These buttons can be useful, say an issue occurs and the sensors stop working. Just something unpredictable. For the meantime, you can just have employees press the button when they're entering and leaving a building. And then I will be testing the sensors and the sensor range by walking by the box. So it's recommended install the box around waist height, and I will just be walking past and the box multiple times, and the count should increase and decrease. And I'll try to also increase the count a couple times. Obviously, it's hard because every time I walk past, the count changes, which is good because it's a very accurate count, but to do this, I'll try to kind of avoid the sensors. I might have to crawl under the sensors to show the incrementing, as you'll see in the design test phase, which I'll show soon. And lastly, I will test the Node-RED local and remote display updates. So first in this test, I am just showing you Node-RED on my laptop, which has a local display, and then I have it on my iPad, which is connected to my personal hotspot on my phone, which has a remote display. And then I will be just pressing the buttons for a bit and showing you how these update together, both locally and remotely. And then I will try and show you how the sensors also update the count locally and remotely as expected, but I will just prove it. Okay, and I'll start the test now. So, the final result.
Hello, this is my ECE 5000 design demonstration. My project was the Arduino in-house/lab people counter using Node-RED for remote and local display. This is my final product in an enclosed box. On this side are my two IR sensors. Based off what direction the person's moving, the IR sensors will pick up whether they're leaving or entering a building. And then on this side, I have an LCD screen that locally displays the people count, which is good for testing. And then I have 3 buttons. This one is a manual increase, this is a manual decrease, and this is a reset button. So now I'll show the wiring. This is clearly the smallest enclosed box. Over here is my soldering board. So I did soldering for this project, and under all these wires is my Arduino, and also the buttons are under all these wires. So yeah, that's my project, and then it closes. Okay, now I will demonstrate the product by me walking through a door frame. As you can see, this is a standard door frame, and I'm gonna try and show the door frame and the count at the same time. Hopefully you can see both. The two white poles. Set this up right. Okay. I'm walking through. Hopefully the count is changing. I forget which direction is which right now, but assuming that's the increasing direction. And if I go under again, we're at 2. Great. And I'm trying to not trigger the sensor so I can see. So it keeps increasing, and then walk by again. Hopefully it's decreasing. I can't see it right now. I'll walk by again. 3, and now I'll go like to the edge of the door frame to show the range. So hopefully it's picking me up. Now I will be going over my Node-RED local and remote display part of my project. Here on my laptop is my Node-RED local display, and on my iPad is my Node-RED remote display, which is also connected to my personal hotspot, which is a different network than the local display. So here is my Node-RED configuration. It's reading a serial input from port 3, which is sending to the local gauge and serving remote access. The easiest way to test Node-RED right now by showing would be to use the buttons on my product. So the LCD screen's on one, so I'll just press the buttons and we can see how the count updates and decreases. So the local display is updated to 4 and the remote display is updated to 4 after I increase the count to 4. So that worked as expected. Now I will decrease the count to 2. So local displays at 2 and remote displays at 2. And so is the LCD screen. Now I will reset the count to hold the reset button. So remote display is also at 0, local is at 0, and the count is at 0. And this also obviously works as I walk past the product. It's just harder to show everything right now, but I'll wave my hand through and we can see the count update. So now it's at 1, I'll put it to 2. I'm just waving my hand through. Remote is also updating. Now I'm going to show that my Node-RED remote and local display update as expected. Hopefully you can see both screens. So I'm just going to walk by for this part so you can see me, but it should just be increasing and decreasing as I walk based off the direction. And that should work as expected since I started at count 5. And I'll just quickly show the entire range of the door frame. I was kind of at the range, but I'll just go further up. So it should be doing the same as before, increasing and decreasing.
In the final phase of this project, all tests performed as expected. A previous problem I occurred during the testing phase was a redundant count. So I was walking by the counter and both sensors would be triggered, so the count would go 1 when I walked past sensor A, then back to 0 when I walked past the second sensor. So it was picking up both sensors as it was walking by, so it was just redundant. It was going to 0 all the time. And this is an issue I was having trouble with, but to fix this issue, I added some logic to my Arduino code, basically some timers, like enough time for me to walk by both sensors when sensor A is triggered first, or sensor B, sensor A wouldn't be triggered, like picking up in that time frame. But yeah, if you have any questions or you want to see, say, my Arduino code, or you have comments and concerns about the building occupancy counter, please reach out to me via email. My email is attached right here. And thank you for watching.